particle physics is a game of statistics, essentially. So it's like tossing a coin 100 times, and it is possible that you'll get 99 heads. Doesn't mean the coin is weighted. There's a possibility. And because we have up 600 million collisions per second on average at LHC, or more, that means you've got huge numbers of collisions, huge amounts of data. So you're always getting things that look like new particles, and then they tend to go away again when you get more data. There's statistics fluctuating around. But we did have hints of which look very like new particles in the old data, and we need to take new data to see whether they go away or not. But one of them, it's a famous thing, it's called the diphoton excess, and it was about 750 times the mass of the proton. Now that's very heavy. The Higgs is 120 odd times the mass of the proton also. So a very heavy new particle it looked like, which was decaying into 2 particles of light. And so you can see that no one knew what this was, because there were over 200 theoretical papers published describing 200 different versions of what it might be. So nobody knows. Nobody knows even if it's there. It might go away. But if it stays, one of the suggestions is that it's this hint of extra spatial dimensions in the universe. So that there are ideas which go back to the 1930s called Kaluza-Klein gravitons, and the idea is that you can have extra spatial dimensions that are kind of curled up small, so we can't see them. And the analogy that's often given, which is a good one, is imagine a hose pipe at the bottom of your garden, and if you're a long way away from it, it looks like a line, sort of a one-dimensional thing. But if you walk up to it, you can see that it's actually curved up into a second dimension, so it's a two-dimensional thing, a cylinder. So space can be like that. And one of the signatures is that you get these signatures of heavy particles, kind of towers of them, almost like harmonics on a guitar string. And this looks like one of those, if it's there. So if we're very lucky, we see hints of something like extra dimensions, then you start being able to probe these effects. So gravity, potentially try to understand gravity by looking at collisions in particle accelerators, and then you're on your way. So if that it's very exciting if it turns out to be true. I just don't know. Many of these things go away when you get more statistics.